Secondary waves, or S waves, are seismic waves produced by an earthquake. As one side of a fault slips past the other, the pressure that had been stored is released and travels radially away from the focus of the earthquake. S waves are lateral waves that move side to side as a sine wave perpendicular to the direction of the wave. They are the second seismic wave to be felt or recorded during an earthquake after the conveniently named primary wave. If you have ever experienced an earthquake, the intensity of the earthquake grows after the first initial jolt. When compared to other seismic waves, S waves are the most destructive of all seismic waves. S waves are more destructive than P waves. The lateral movement of the wave produces a rolling effect along the surface that can cause damage to all types of structures. During the 1989 Loma Prieta earthquake in San Francisco, S waves were especially destructive. Parts of San Francisco were built on wet, sandy soils. When the S wave passed through these soils, a process called liquefaction occurred that shook the soils so much it essentially acted as a liquid. S waves travel slower than the primary waves. We can use the time difference between the arrival of the P wave and S wave to determine how far the epicenter is located from the location recording. One location can determine its distance to an epicenter. Two locations can narrow the epicenter down to 2 places. 3 locations can pinpoint the epicenter of the earthquake. Another important property of S waves is its inability to pass through liquids. After an earthquake, most Richter scales around the globe can detect P waves, but less are able to detect S waves. This is known as a seismic shadow zone, and each earthquake has a different one. The cause was found to be due to the layered composition of the Earth's interior, some of which are solid while others are liquid. P waves have the ability to pass through both solid and liquid layers, while S waves are only able to pass through a continuous solid layer. This finding allowed scientists to study the interior of the Earth by determining where S waves would and would not appear. S waves, or secondary waves, get their name from arriving after the primary wave. While they travel slower than P waves, they cause considerably more damage, including liquefaction of loose soils. S waves are important in determining the location to the epicenter of an earthquake by calculating the difference in time of the arrival of the P and S waves of various locations. Scientists have been able to use S waves to determine the layers of the Earth's interior by studying seismic shadow zones caused by them.